See this one example. Excuse me. So we have seen how to configure the interrupt, the core group peripheral. Now let us see how the interrupt service subroutine actually works. Where do we actually configure it? So here, let us look at this example. It says write a main program and interrupt zero interrupt service routine. So this interrupt service routine is what we call as, it's a subroutine, what we call as interrupt service routine or subroutine. Excuse me. So this is the given circuit. So you can see the interrupt zero, there is a frequency square wave signal which is actually coming in. So what the question says that initialize a counter, enable interrupt zero and stay in the loop. So what it's supposed to do is each time whenever the clock signal goes down, each time when it goes down, we want it to be triggered. We want the triggering to happen at each time the square wave signal changes logic from 1 to 0. Alright, so each time whenever it changes the logic, we want it to generate the interrupt. So each time when interrupt happens, what we want it to do, the interrupt zero's interrupt service routine is supposed to increment the counter by 1 and output to the LED. So this is connected to port D, and what kind of configuration is this? This is the sync in configuration. So which means you have to give logic 0 to turn on the LED. Okay, so let us see how we can actually write the code. Oops, sorry, go back. So let me see if I can select. I'm just going to select this and I'm going to put in the note. Copy. Let me go to the note. Let's go new page, and let me see how to paste it here. Okay, somehow I'm not so sure why the paste thing is not coming. Okay, never mind. Actually will try to draw this. Okay, so you have seen the circuit just now. So we are dealing with port and also interrupt. So remember, whenever you see the port, the first thing that you want to do is you want to configure the interrupt. You want to configure the ports. So now we're going to write the full program. So how do we want to write the full program? So here we're going to start with the origin hex 00. Then you have go to start. Now we have origin hex 08. Now if you remember from our earlier session, this is the interrupt vector for high priority interrupt. Okay, so in our question, interrupt 0, remember, is by default high priority. So we can actually use the 08. So I leave some space here. Later I'll explain how we can actually do about it. So let's go to the, let's go to the start. So I leave some space here. Start. So under the start is the first thing that we want to do is we want to do the configuration of the port. So we are dealing with port D. So we want to actually clear F tris D so that it config port D as output. Okay. And if you look back at this circuit, this one, the configuration is, this is a sink in current. So in order for you to turn it on, you have to give logic 0. So the initialization that we want to keep this is we want to off all of this. So what we do, we actually give logic 1 so that all the LEDs will be off initially. All right. So what's the initialization? We want to set F port D so that off all LEDs. Okay, so this is on configuring and initializing the port. Do we have any input port? Now be careful that here, even though this INT0 is actually RB0, we are not configuring it as a digital input pin. We are configuring it as interrupt. So that is why we are not configuring TRIS-B. We are not doing that. Okay, so have that clear. So the next thing that we want to do is we want to configure the interrupt. So interrupt 0 is by default high priority. It's by default high priority. You cannot change it to low priority. So which means now we want to configure bit set F, RCON, IPAN. This is by default always comes. Okay. Then what we want to do, we want to always clear the flag right. So the flag of incon, where is it? So INT0 flag is in incon and INT0 enable is also in incon. GIEH is also in incon. Take note that interrupt 0 doesn't have priority bit. So what we're going to do, interrupt 0 flag we clear, and then what we want to do, we want to enable INT incon interrupt 0 IE. We want to enable it. So are we done? Remember the rule is this is a high priority interrupt. So and it is also a core. So you have two levels of interrupt. So the first level is here. This is local, and you also now must enable the global write. So bit set F incon GIEH. So this is the global. Now the interrupt is enabled. So the interrupt part is done. Now once you have enabled the interrupt, what it means, oh sorry, one more thing I forgot. My bad. Because here in the questions we said that we want it to interrupt every time it changes logic from 1 to 0, right? So there is one more configuration. You only apply this when the question says for you to check on the interrupt edge. So if we see here under the incon 2, there is this interrupt edge 0. This is actually for interrupt 0. So interrupt edge 0. So interrupt edge 0 means you want the interrupt to be generated when it actually changes from 1 to 0 or 0 to 1. So this is actually on the interrupt edge. So we are actually going to use this edge, interrupt edge. So let's go, where is it? Here. So that we can actually include somewhere here. Sorry, I just missed one line, so I'm just going to add. Okay, so you just can write. So here, because you want it to the interrupt edge, you want it to get from 1 to 0, right? So therefore you clear. So bit clear F in con 2 interrupt edge 0. So this will make sure the interrupt happens when it is becoming logic 0. If you want to detect when it comes logic 1, then you bit set F. Okay, so this is the additional thing. If the question asks you to check on the which edge that it should trigger the interrupt. Okay, so now you have done the configuration of interrupt. So go back to this question. It says that you also need to have a counter. Why we need to actually have this counter? Because this counter is each time when the logic changes from 1 to 0, you want it to generate the interrupt and to increase the counter by 1 and output to the LED. That's what you want to do. Okay. So by default, we've already set the port D, we already cleared. But let's say we want to use product L as our counter. So what we can do is we can clear F product L. So clear F product L. So this is we use as our counter. Okay, so after you have done initializing the counter, what do you need to do? There's nothing more for you to do. So you just have to wait for the interrupt to happen. So wait for the interrupt to happen means what? Wait for the signal to go, the square wave signal go up and down, square wave signal. Right? Each time whenever it sees this, it will trigger the interrupt. So what you have to write here, wait for interrupt means you can actually write no operation, branch, wait. Then you put wait here. So remember in the early or at the onset of this chapter, I did mention that here we are actually talking about a subroutine. But the subroutine you don't actually have to use call or rcall. It will be whenever there is an interrupt happen, it will be called automatically. So you have already done the configuration here, right? So the next thing is you need to wait. So the PC will keep on rotating here, right? The PC program counter will keep on rotating. So what happens is when it detects the first one, whenever the first signal comes at INT 0, assuming that the program counter is actually moving between these two lines, right? It'll keep on looping. This is what we mentioned. It'll keep on looping here. So let's say assuming the PC is actually pointing here. So while PC is here, assuming that the signal comes in. So what it does, it will store the address of the next instruction. Same concept as how we call a subroutine, right? It will save the address of the next instruction into the return address stack and where the PC will go. Now before this, when we use call function, for example, call delay subroutine, when the instruction is executed, just to recall all of you, let's say we have this call delay subroutine. When this instruction is executed, what the PC does, it takes the address of the next instruction, it stores it into the return address stack. And the PC from here, it will go where? It will go to the delay subroutine, right? Then you have the return, right? This is the delay subroutine. The PC will go here. Why? Because you already given where to go when you call. So the PC will point to the delay subroutine, and when you come return, what return does? Return will extract back the address of the next instruction so that it knows to go back here. So this is how it actually works. Same concept, only here. So here it will do the same thing. If assuming that the PC while it's pointing here, the interrupt happens. So what it does, this will stop. So when the interrupt happens, what it means, the flag becomes 1 actually. The flag bit becomes 1. So when the flag bit becomes 1, then only this thing happens. It will stop. It will take the next address instruction. It will keep it, store it in the return address stack. And now where PC will go? Now remember, this is a high priority interrupt, right? So the PC now will go here, hex 08. Because by default, high priority interrupts will go to 08. So that's why by default it will come here. So here is the space where we're supposed to write the subroutine. But the subroutine is not going to be just one line, right? It's going to be several lines. So we don't know how much of space to keep here. So one of the best practice that we do is we can actually use instruction like go to and a subroutine name. So we can call it this as interrupt service subroutine underscore int 0. Okay. Then here we can actually keep origin 18 retfie. So this one we are not going to use because in this case we are only using the high priority. Remember that this is the interrupt vector. Maybe write this thing properly. 18. This is the interrupt vector for low priority. So if we configure as low priority, then it will come here at 18. But now we do this. So because you put go to, it now the PC from here we will go here. We will write our subroutine here. Interrupt service subroutine int 0. So the PC, which actually comes here at address 08, and you have the instruction go to ISR int 0. So from here it will go here. Now here's the thing. This is the interrupt service routine. Okay. The first thing that you want to do is you want to clear back the flag. This is always for interrupt service routine. The first thing that you want to do is you want to clear back the flag. So the flag that we're looking at is int 0 flag. This is always must clear the flag, because if you don't clear the flag and after you execute the interrupt service subroutine, and if you go back to the main program, again it will stop and it will go to the interrupt service routine. Remember earlier I mentioned that this main program stopped and it saves the address of the next instruction and then goes to here 08 because the flag is 1. That's why. So in order for it to repeat back, you always need to clear the flag. Okay. So here, the format of this interrupt service subroutine is always like this. You always have clear the flag, and you will have whatever task that you want to do, and then you return from interrupt. This is always the standard. So here we don't use return, we use retfie. Now on another note, what this retfie also means is that when the interrupt happens, when interrupt is executed, take note that the GIE or GIEH will be disabled. It will be disabled. Meaning, what it means that while you are running interrupt service subroutine, you cannot trigger another interrupt because this is disabled. The moment you come to RETFIE, what RETFIE will do is that it will enable back the GIEH, and then it will return to the address that has been stored. So it knows where to return back to the next instruction. So that is RETFIE. It does these two things. Okay. So let us erase this. So we have to write the task. So the task is we're supposed to increase by 1, right? So we already have a counter which is product L. So how do we want to increase the counter? I think we have the increase instruction. So the increase instruction, where is it? So it has 3 fields, F, D, A, right? So we're going to have increase file register. We're going to increase product L, and then we're going to store the results in the file register. So this is increase. Now what we need to do, we need to now move this data to port D. But there is an issue here. The issue here is that here it has to be reverse. By right, when we actually increase by 1, the logic will be like this: 0, 0, 0, 0, 0, 0, 0, 1, right? But here if you put 1, 0, 0, 0, 0, 0, this LED, the first LED will be actually, oh sorry, what am I doing? My bad. Here's 0. So when you have the 1, 0, 0, 0, 0, 0, 0, 0, what happens is only this LED will be off, the others will be on. So if you want to keep that way is also fine, which means the number that it increase will be shown by the LED that is off. So that means if this first LED is off, it shows that, oh, it is 1. And if this LED is off and the others are on, it shows is 2. But if you find if that's actually confusing, what you can actually do is you can complement this. So when you complement or toggle this, then it becomes 1, 1, 1, 1, 1, 1, 1, 0. Right? Then what happens? You can rightly see that this will be on, then all the others will be off. So how do we actually do that? So we can use complement file register. Is this the correct code? Let's see. COMF. So correct. Complement F. COMF. We want to complement product L, but maybe now we will store it in working register. We don't want to disturb the product L because the product L is actually increased by 1, right? So now we complement the product L, but we store it in working register. And then what we do, we can actually now move FF working register to port D. So in this way, we are able to see. So our task is done. Then we can use RETFIE, return from interrupt. So here is where you're supposed to write your end. Is that okay? So this is the full cycle of interrupt service subroutine. So again, let's go through the flow of the code. So the first thing is, we can see we actually initialize the port and then we configure the interrupt. We also initialize the counter and then we wait for the interrupt to happen. Now in the interrupt service routine, when the trigger happens, then what happens? It stops, it saves the address of the next instruction into return address tag, and the PC now will go to 08. By default, it will go to 08 because you configure this as high priority. Sorry, because interrupt 0 is by default high priority. But let's say if you're working with interrupt 1, interrupt 2 and you configure as high priority, all high priority, the PC will come here to 08. If it's low priority, it will come here, 18. So I hope you are clear on that. But because We do not, by right, here is the place that we're supposed to write our this entire subroutine. We're supposed to write it here, but we don't know how many lines to keep right. So one of the practices we put go to interrupt service routine, so that the PC will execute this line and then will come here. So here the first thing, always must clear the flag back. Then you increase the product L, then you do complement, store at the working register. Then from working register, you store to port D. Then you do RETFIE. So RETFIE, what you'll do, it will enable back the global and also return the address, saved address. So the PC will come back here. And then what it does, it keeps on waiting for the next one. So like this, each time it happens, it will go like this. So if there's any question, please do ask in the group so that everyone can learn.